Alright class, in this session we are going to start the new exercise on that is topic kinematics. Alright, now kinematics we had done in maths as well. Hello. So in kinematics we are going to discuss about distance, displacement, velocity and acceleration. These four are important parameters that we are going to discuss in this topic. And kinematics is basically the application of calculus. That means it's an application of differentiation and integration. But the concepts we have learned in differentiation and integration, we are going to apply these concepts in this topic. So if I ask you a very basic question that what is the difference between distance and displacement, right? You know that one requires direction and the other requires, there is a need to define direction for distance. But for displacement, there is a need to define the direction as well. Let's suppose that we have a point A and we have a point B. Mr. P travels from A to B in this direction. Alright, so that is the distance of Mr. P from A to B. But Mr. Q, he travels from A to B in a straight edge, shortest distance, and that is basically a displacement. So displacement is the shortest distance between two points. Alright. Now there are some very important parameters that I have written in the form of notes. So what you need to do, you have some common phrases. These phrases you will see in the question. And whenever you see such phrase, you need to highlight that phrase. And the meaning of that phrase is, let's suppose it says, t seconds after passing a point, it means that when time is 0, its distance is 0. S defines distance or displacement, right? So firstly, you need to write down all the points in your copy, and here we have not maximum, it's for minimum velocity, and the second one is for maximum. Alright, so first you need to write down all the phrases in your copy in the same way that I have pasted on your screen. So firstly, you have a time of 5 minutes to note down all the important things in your copy, and then I will tell you that how to use such conditions while you are doing the question. So start. Done? Alright. So let's start with question number 1 here. It says a particle moves in a straight line so that its distance from a fixed point O. Now I hope that you have a condition with this statement. is given by distance is equals to t times t minus 6 whole square, where t is time in seconds after passing O. Find the velocity of p when t equals to 1. Alright. When you have a distance and you need to find velocity, that means now we need to start with the differentiation. When you derivate your function of distance, so you will get the velocity. So it means that I need to derivate the function as you have on your screen, right? But before that, I will solve the equation. So it's t square minus 12p plus 36, and if you multiply with t, so it's t cube minus 12t square plus 36t. Now that is your expression for distance, right? So now you need to derivate the function to find out the velocity. So we need to derivate the function with respect to time, right? Because the independent variable we have time here, and on the right side as well. Now you know very well how to derivate the function. We have learned the topic differentiation in very detail. You need to give it a try first, and you have a time of 2 minutes to start. Alright, so ds upon dt is basically equals to velocity. The derivative of t cube is 3t square minus the derivative of 12t square. So first we need to write down the power. So 12 times 2 is 24t, and the derivative of 36t is 36. Alright, so you have an expression for velocity. In the question it says find the velocity when t equals to 1. So now you need to substitute the value of t here. So when you place the value of time in this equation, so you will get volume is equals to 3. The value of time is 1, so it will be 3 minus 24 plus 36, right? So 3 plus 36, 39. So you will get 39 minus 24 gives you the value of 15 meters per second. That is the value of velocity when the value of time is 1. Alright. For part B, it says the value of t when p is instantaneously at rest. Now, the important statement that we have discussed, when it says instantaneously at rest, it means velocity is 0, right? So for part B, we know that the condition is velocity is 0, right? So the velocity expression we have find out in part A. So we have velocity is equals to 3t square minus 24t plus 36. The value of velocity is 0. So 0 equals to 3t square minus 24t plus 36. We can take common 3 here. So if I take common, so it really simplifies. T square minus 8t plus 12 equals to 0. When you shift 3 on the left side, it will be 0 equals to t square minus 8t plus 12 equals to 0. Now you have a quadratic equation here. We can solve it by applying middle term. So the two factors I have is 6 and negative. Right? We have applied middle term here, and now we can take common here. The common is t. Inside the bracket it's t minus 6. Minus 2 inside the bracket it's t minus 6. Again we can take common, that is t minus 6, and the leftover is t minus 2 equals to 0. Now we need to equate both of the functions with respect to 0. So it's t minus 6 equals to 0 and t minus 2 equals to 0. So you will have t equals to 6 and you will have t equals to 2. These are the values of t that you need to find out in part B. Alright, now you need to write down the solution in your copy, and for that part you have a time 90 seconds, so start. Alright, so that is for part B. For part C, it says the acceleration of p when t equals to 3. Now, acceleration is what? Acceleration is you need to derivate your velocity, right? Because rate of change of velocity is equals to the acceleration. The expression for velocity we have is velocity equals to 3t square minus 24t plus 36. We need to derivate the function, so it's dv over dt, and on the left side we need to derivate the function. So dv over dt we have is equals to acceleration. When you derivate 3t square, it's 60. When you derivate minus 24t, it's minus 24, and the derivative of constant is 0. Alright, so you have the expression for acceleration. Once you had the acceleration expression, the value you need to insert is 3 here. So acceleration at t equals to 3. So it will be 6 times 3 minus 24. 6 3s are 18 minus 24. So acceleration equals to minus 6 meters per second square. That is your answer. So you need to write down the solution in your copy, and for that part the time is 90 seconds, so start. Alright, moving on towards the next question. Question number 2. It says a particle moves in a straight line and its displacement x meter from a fixed point O. T seconds after passing O is given by, you have a expression for displacement and it is equals to 12t minus t cube. Alright. Calculate the acceleration of the particle when it comes instantaneously to rest. So now we know that what do you mean by instantaneously at rest. It means the velocity for this part is equals to 0, right? You have the expression for displacement, and from displacement how you need to find out velocity. It's very simple. You need to derivate your function. When you find out the derivative of displacement or distance, you will end up at velocity. So dx upon dt, its velocity, is equals to derivative of 12t, it's 12, minus t cube, it's 3t square. There is no need to write down the solution. I will give you time for that. So for the first part, we have velocity equals to 12 minus 3t square. It says instantaneously at rest. Now we need to place velocity to 0 and find out the value of t here. So if I make t the subject, it will be 12 equals to 3t square, 4 equals to t square, applying root, so it's t equals to 2. We are not going to take minus 2 here because time can never be a negative quantity. For first part, it says find out the acceleration, right? So what is acceleration? Acceleration is basically the derivative of velocity, right? So you have the expression for velocity which we had find out earlier. Velocity equals to 12 minus 3t square. For acceleration, you need to derivate your velocity. Alright. So the derivative of velocity, its acceleration, the derivative of 12 is 0, minus the derivative of 3t square, it's 6t. Alright, so you need to find out the numeric value of acceleration, and for time, we had find out the value of time previously, that is 2. So acceleration equals to minus 6 times 2 is equals to minus 12 meter per second square. That is your acceleration. No need to write down. I will give you time for that. Moving on to the next part, B. The velocity of the particle when it is next at O. Now, what do you mean by next at O? Let's suppose that the particle starts at this point, right? That is the starting point. So let me say that it's S. Particle start from this point, travel around it, and when it come back to O, and after that we say that now it's next at O. So for next at O, it means that distance or displacement equals to 0. That is meant by next at O. Alright. Now we have the expression for displacement. It's given 12t minus t cube. So for the condition next at O, we know that the displacement is 0. So instead of x, I will place 0 here, which is equals to 12t minus t cube. Now we need to solve this equation. So t, you can take common here. Inside the bracket, it's 12 minus t square equals to 0. So t equals to 0 and 12 minus t square equals to 0. So you will get the value of t square, that is equals to 12, and for t is equals to under root 12. We can find out the root value of 12, and that is equals to 3.46. Alright. For second part, the velocity we need to find out when it is next at O. So what is the expression for velocity we have? We had find it previously. Velocity is equals to 12 minus 3t square. The velocity of the particle when it is next at O. So we had find when the particle is next at O, the value of time is 3.46. So velocity is 12 minus 3 t square. T square is basically 12. So I'm placing the same value 12. So now it is equals to 12 minus 12 threes are 36. It leads to negative 24 meters per second. That is your velocity. Alright. And after the velocity part, it says the distance traveled by the particle during the first 3 seconds. Alright, so how you are going to find for the distance? There is a method to find out the distance. The value for displacement, the expression for displacement we have, it's x equals to 12 t minus t cube, right? We need to find out the distance particle traveled during the first 3 seconds, right? So we need to find out the distance at t equals to 0, at t equals to 1, at t equals to 2, and t equals to 3. The same method we are going to opt in every question where we need to find out the distance, right? Okay. So let's suppose when I place the value of t0 here, so 12 times 0, 0 minus 0. So at distance, when time is 0, distance is 0, right? When time is 1, so I'm working with the green pen, at time equals to 1, so distance equals to 12 ones are 12 minus 1, it's 11. So the distance is 11. After that, at time equals to 2, so distance is equals to 12 times 2 minus 2 cube. 12 twos are 24 minus 8, so 24 minus 8 leads to 16. So when time is 2, distance is 16. At time equals to 3, distance equals to 12 into 3 minus 3 cube. 12 threes are 36 minus 27, it is equals to 9. Alright, so we need to find out the distance the particle traveled during the first 3 seconds. During the first 1 second, the particle travels 11 minus 0, it's 11. In the time between from 1 to 2 seconds, the particle travels 16 minus 11, it's 5. And between 2 to 3 seconds, it will be 16 minus 9. Alright, so that is equals to 7. So the total distance the particle traveled is the sum of these three. 7 plus 5, 12 plus 11 leads to 23 meter. That is the distance traveled by the particle during the first 3 seconds. Alright, so that is your final answer. And keep in mind that whenever you have a question in which it asks find out the distance or the average speed, for distance part we always make a table in this form that we are going to suppose the value of time in the equation of distance, find the value, and then find out the difference of these distances to find out the distance the particle traveled during this specific time interval. Alright. Now you need to note down the complete solution in your copy, and for that complete part you have a time of 5 minutes to note down the solution in your copy. So start. Alright, done. Moving on towards the next question. It's question number 3. A particle moves in a straight line so that its displacement from a fixed point O is given by the equation you have. For first part, we have the equation x equals to 3t square minus 4t cube plus 6t. Where t is time in seconds measured from the start of the motion, calculate the initial distance of t from Q. The word initial distance, it means, or the condition means that when the value of time is 0. So when you place the value of time 0 in this equation, you will get the initial distance. So that will be 0 minus 0 plus 60. It leads to 60 meters. That is your first part answer. Alright, so keep in mind that whenever it says initial distance, initial means when the value of time is 0. For part B, the magnitude of acceleration of t when it is instantaneously at rest. You have the equation of distance, it's x equals to 3t square minus 4t cube plus 6t. Instantaneously at rest means velocity is 0. So first we need to find out the velocity by derivate the distance equation, and then equate it to 0 because it says instantaneously at rest. So find velocity and then velocity equals to 0 to find the value of t. So first do it and then I will explain to you the correct answer. So we have a time of 2 minutes. Start. Alright. When you derivate it, it will be 16 minus 12t square, and when you place velocity equals to 0, it's 6t can be taken as common. 1 minus 2t equals to 0. Equate both of the functions to 0, 60 equals to 0 and 1 minus 2t equals to 0. So you will get t equals to 0 and you will get t equals to 1 upon 2. Alright, but we don't know, the main task is not to find out the time, the main task is to find out the acceleration, right? And acceleration is what? When you derivate the velocity. So we have the velocity expression, derivate it, find out acceleration and then put the value of time equals to 1 upon 2. So you have a time of 2.5 minutes for this part, so start. Alright, so the velocity is 60 minus 12t square and the acceleration is 6 minus 24 times t. The value of t we have, it's 0 and 1 upon t. At t equals to 0, acceleration equals to 6. At t equals to 1 upon 2, acceleration equals to 6 minus 24 times t is what? It's 1 upon 2. So that leads to 12 and 6 minus 12 leads to negative 6. So these are the two values of acceleration as your final answer for part B. Alright, after part B, part C, the average speed of P over the first 2 seconds. So what is average speed? Average speed is total distance divided by total time. Alright, distance divided by time. It says for the first 2 seconds. Alright, that means for first 2 seconds we have t0, we have t1 and we have t equals to 2. Right, the distance equation already given in the question, that is x equals to 3t square minus 4t cube plus 60. So for the first part, when t is 0, so when t is 0, the leftover part is 60. So when t is 0, distance is 60. When t is 1, so I will place the value of t 1 here. So it's 3 minus 4 plus 60. It's 59. Alright. But before that, we have one more special value, that is 1 upon 2. Right. So we are going to incorporate this value as well. So now at t equals to 1 upon 2, at t equals to 1 and t equals to 2. So when t equals to 1, we got the value, that is 59. What is the value when t equals to 1 upon 2? Alright. So at t equals to 1 upon 2 equals to x equals to 3, t is 1 upon 2 square, it's 1 upon 4, minus 4, 1 upon 2 cube, it's 1 upon 8 plus 60. So that is equals to 3 divided by 4 minus 1 divided by 2 plus 60. So take LCM here, it's 8, not it's 8, it's 4. So it will be 3 minus 2 cubes are 4 plus 1 into 4 and 60 into 4, it's 240. Right, so the distance we have, it's 241 divided by 4. In decimal, its value is 241 divided by 4, it's 60.25. Alright, so the distance is 60.25. And when t equals to 2, at t equals to 2, I am putting the values in this equation. Alright, so it's x equals to 3, 2 square is 4, minus 4, 2 cube is 8, plus 60. 3 4s are 12, minus 4 8s are 32, plus 60. So 62 plus 12 minus 32, it's 42. So the distance value is 42. Now we need to find out the difference between these two. 60.25 minus 60 is 0.25. These two. 60.25 minus 59, it's 1.25. And for the last two, 59 minus 42, it's 70. You can observe that always I figure what I'm doing, that I'm taking a difference from highest minus lowest. Now I need to add these two. 17 plus 1.25 plus 0.25 leads to 18.5, and that is your answer. So firstly, it's tx equals to not 42, it's 40, right? And this distance will be the same because it's 40. Now the difference is not 70, it's 19. And when you add, it will be 19 plus 1.5, it's 20.5, right? That is your distance. We are looking for average speed here. So average speed, the total distance we have is 20.5 divided by. What is the value of time? It says over the first 2 seconds, so the value of time we have, it's 2. 20.5 divided by 2 leads to 10.5, and that is your final answer. So I think it is quite enough for today's class. Inshallah, in next class we are going to continue the same topic. Till then, take care.